Overloading can be a potential cause. The switch may be handling too much load, causing it to overheat and spark. It is important to check the wattage of the lights or appliances connected to the switch. Loose connections can also be a problem. Make sure that all connections, including the screw terminals, are tight and secure. Loose connections can create resistance, leading to overheating. Another possibility is damaged wiring. Inspect the wires connected to the switch for any damage, such as nicks or abrasions. Damaged wires can cause arcing and sparks. The replacement switch itself may be defective. Removing and replacing it with a new one is a possible solution. Even when this switch is off, there may be a small amount of voltage present in the circuit, known as ghost voltage. This can cause the switch to spark or trip. To troubleshoot these problems, firstly, disconnect power. Shut off the power to the circuit at the breaker panel. Secondly, check the load. Calculate the total wattage of the lights or appliances connected to the switch. Make sure it does not exceed the maximum rating of the switch. Thirdly, inspect connections. Tighten all screw terminals and wire connections securely. Fourthly, check wiring. Use a non-contact voltage tester to check for any voltage present in the circuit when the switch is off. If there is voltage present, consult an electrician. Fifthly, replace the switch. If all else fails, remove and replace the switch with a new one. Additional considerations may include circuit overload. If the switch is overloading, it may trip the circuit breaker. Reset the breaker and limit the load connected to the switch. A ground fault is another consideration. Make sure that the circuit is properly grounded. A ground fault can cause arcing and sparks. It is important to always disconnect power before working on electrical equipment. Use proper safety gear, including insulated gloves and tools. If you are not comfortable troubleshooting electrical issues, contact a qualified electrician. Switches are rated for both amps and volts. Common residential switches are rated for 15 amps or 20 amps at 120 volts. Make sure the switch rating is adequate for the circuit. To determine the load on a switch, you need to calculate the total amperage drawn by all devices connected to the switch. For incandescent lights, the wattage is usually printed on the bulb. To find the amps, divide the wattage by the voltage 120 volts. For example, a 100-watt bulb draws 100 divided by 120, which is 0.83 amps. For other appliances, the amperage is usually listed on a label on the device. If the wattage is listed, divide the wattage by the voltage 120 volts to find the amperage. Add up the amperage of all devices connected to the switch. The total amperage should not exceed the switch rating. Wire connectors, such as wire nuts or push-in connectors, are used to join two or more wires together. These connectors must be properly sized for the number and gauge of wires being connected. Loose wire connectors can cause a high resistance connection, which can generate heat and cause a fire. Make sure the wire connectors are tight and properly installed. Aluminum wiring was used in some homes in the 1960s and 1970s. Aluminum wiring can be a fire hazard if it is not properly installed and maintained. Aluminum wire expands and contracts more than copper wire, which can cause connections to loosen over time. If you have aluminum wiring, have it inspected by a qualified electrician. Grounding is an important safety feature of electrical systems. A ground wire provides a path for electricity to flow back to the source in the event of a short circuit. This helps to prevent electrical shock and fire. Make sure all electrical circuits are properly grounded. A ground fault circuit interrupter, or GFCI, is a safety device that protects people from electrical shock. A GFCI monitors the current flowing in a circuit and trips the circuit breaker if it detects a ground fault. GFCIs are required in bathrooms, kitchens, and other areas where there is a risk of water exposure. An arc fault circuit interrupter, or FSI, is a safety device that protects against electrical fires. An FSI monitors the current flowing in a circuit and trips the circuit breaker if it detects an arc fault. Arc faults can be caused by damaged wiring, loose connections, or faulty appliances. FSIs are required in bedrooms and other areas where people sleep. When troubleshooting electrical problems, it is important to use the right tools. A non-contact voltage tester can be used to detect the presence of voltage without touching the wires. A multimeter can be used to measure voltage, current, and resistance. Wire strippers are used to remove insulation from wires. Pliers are used to grip and bend wires. Screwdrivers are used to tighten and loosen screws. Always use insulated tools when working with electricity. National Electrical Code, or NEC, is a set of standards for electrical wiring and equipment. The NEC is updated every 3 years. The electrical inspectors use the NEC to ensure that electrical installations are safe. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It is important to be familiar with the NEC when working with electricity. A qualified electrician has the training and experience to safely troubleshoot and repair electrical problems. If you are not comfortable working with electricity, contact a qualified electrician. Working with electricity can be dangerous. Always take precautions to protect yourself from electrical shock and fire. Disconnect power before working on any electrical equipment. Wear insulated gloves and shoes. Use insulated tools. Never work on electrical equipment when you're wet. Be careful when working around water. Coal before you dig. Know what's below. Electrical circuits are protected by circuit breakers or fuses. These devices are designed to trip or blow when the current exceeds a certain level. This protects the wiring and equipment from damage. If a circuit breaker trips or a fuse blows, investigate the cause before resetting the breaker or replacing the fuse. Common causes of trip breakers and blown fuses include overloaded circuits, short circuits, and ground faults. An overloaded circuit occurs when too many devices are connected to the same circuit. This can cause the wires to overheat and potentially start a fire. A short circuit occurs when a wire comes into contact with another wire or a grounded object. This can cause a large current to flow, which can trip the breaker or blow the fuse. A ground fault occurs when current flows through an unintended path to ground. This can also cause a large current to flow, which can trip the breaker or blow the fuse. When troubleshooting electrical problems, start by checking the circuit breaker or fuse. If the breaker is tripped or the fuse is blown, reset the breaker or replace the fuse. If the breaker trips or the fuse blows again, there is a problem with the circuit. Investigate the cause of the problem and correct it before resetting the breaker or replacing the fuse again. Electrical wiring is typically made of copper or aluminum. Copper is a better conductor of electricity than aluminum, but it is also more expensive. Aluminum wiring was used in some homes in the 1960s and 1970s because it was cheaper than copper. However, aluminum wiring can be a fire hazard if it is not properly installed and maintained. Aluminum wire expands and contracts more than copper wire, which can cause connections to loosen over time. Loose connections can create a high resistance, which can generate heat and cause a fire. If you have aluminum wiring, have it inspected by a qualified electrician. They can make recommendations for upgrading the wiring to improve safety. The electrical outlets are designed to provide a safe and convenient way to connect electrical devices to the power supply. Outlets are typically rated for 15 amps or 20 amps at 120 volts. Make sure the outlet rating is adequate for the devices that will be connected to it. Do not overload outlets by plugging too many devices into them. This can cause the wires to overheat and potentially start a fire. Extension cords are used to extend the reach of electrical outlets. Extension cord should be used sparingly and should not be used as a permanent wiring solution. Use extension cords that are rated for the amperage of the devices that will be connected to them. Do not use extension cords that are damaged or frayed. Do not run extension cords under rugs or furniture, as this can trap heat and create a fire hazard. Light switches are used to control the flow of electricity to lights and other devices. Switches are typically rated for 15 amps or 20 amps at 120 volts. Make sure the switch rating is adequate for the devices that will be connected to it. Replace switches that are damaged or worn out. Dimmer switches are used to adjust the brightness of lights. Dimmer switches are typically rated for a specific wattage range. Make sure the dimmer switch is compatible with the type of light bulb that will be used. Three-way switches are used to control a light from two different locations. Three-way switches require special wiring. If you are not familiar with three-way switch wiring, consult a qualified electrician. Electrical boxes are used to protect electrical connections. Boxes are typically made of metal or plastic. Make sure the electrical box is properly sized for the number of wires that will be contained in it. Do not overload electrical boxes. Securely mount electrical boxes to the wall or ceiling. Conduit is used to protect electrical wiring from damage. Conduit is typically made of metal or plastic. Use conduit in areas where wiring is exposed to physical damage. Securely fasten conduit to walls and ceilings. Electrical tape is used to insulate electrical connections. Use electrical tape that is rated for the voltage of the circuit. Wrap electrical tape tightly around the connection to ensure a good seal. Wire nuts are used to connect two or more wires together. Use wire nuts that are properly sized for the number and gauge of wires that will be connected. Twist the wires together tightly before installing the wire nut. Make sure the wire nut is securely fastened to the wires. Grounding wires are used to provide a path for electricity to flow back to the source in the event of a short circuit. Grounding wires are typically green or bare copper. Connect grounding wires to all metal electrical boxes and equipment. Make sure the grounding wires are securely fastened. Bonding is the process of connecting all metal parts of an electrical system together to create a common ground. Bonding helps to prevent electrical shock and fire. Bond all metal water pipes, gas pipes, and ductwork to the electrical grounding system. Make sure the bonding connections are securely fastened. Surge protectors are used to protect electrical equipment from voltage spikes. Voltage spikes can be caused by lightning strikes, power surges, and other events. Surge protectors divert excess voltage to ground, protecting the equipment from damage. Use surge protectors on sensitive electronic equipment such as computers, televisions, and stereos. Uninterruptible power supplies, or UPSs, are used to provide backup power in the event of a power outage. UPS contain a battery that provides power to the equipment when the power goes out. Use UPS on critical equipment, such as computers and servers. Generators are used to provide backup power in the event of a power outage. Generators can be portable or stationary. Connect generators to the electrical system through a transfer switch. This prevents power from flowing back into the utility grid, which could endanger utility workers. Electrical fires can be caused by a variety of factors, including damaged wiring, overloaded circuits, and faulty appliances. If you have an electrical fire, evacuate the building immediately and call the fire department. Do not use water to extinguish an electrical fire. Use a fire extinguisher that is rated for electrical fires. Regular electrical inspections can help to identify potential problems before they cause a fire or electrical shock. Have your electrical system inspected by a qualified electrician every few years. The information provided in this narration is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or troubleshooting. Safety should always be the top priority when working with electricity. If you are not comfortable working with electricity, contact a qualified electrician. The NEC Table 310.15b16 provides ampacity ratings for conductors. When selecting conductors, make sure the ampacity of the conductor is sufficient for the load. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overload. The size of the overcurrent protection device should be selected based on the ampacity of the conductor. The NEC Article 250 provides requirements for grounding and bonding. Grounding and bonding are essential for electrical safety. Make sure all electrical systems are properly grounded and bonded. The NEC Article 408 provides requirements for switchboards and panel boards. Switchboards and panel boards are used to distribute power to branch circuits. Make sure switchboards and panel boards are properly installed and maintained. The NEC Article 430 provides requirements for motors and motor circuits. Motors are a common electrical load in many buildings. Make sure motor circuits are properly designed and installed. The NEC Article 500 provides requirements for hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. Electrical equipment used in hazardous locations must be specially designed and installed to prevent ignition. Electrical safety is a critical concern in all types of buildings and facilities. By following the NEC and other applicable standards, it is possible to create a safe and reliable electrical system. Remember to always consult with a qualified electrician for any electrical work or troubleshooting.